Good morning, everyone, or I guess it's good afternoon now. It's just after 12, and I want to welcome you to the Southern California Water Dialogue. My co-host, Connor Everts, hopefully will be joining us in just a couple of minutes, but we wanted to let you know that we're appreciative of your attendance today, and we have a really great program for you. So I'm going to go ahead and walk through some of the introductory rules for those of you that have not been a participant in the dialogue before. Then we'll go through and explain exactly how we dialogue. It used to be different when we were all in a room together, but we've really benefited from this new virtual world that has allowed for us to have fabulous speakers from all over. And we invite you on our journey today. So real quick, most everybody's gotten used to the Zoom world, but there is a group behind us all that makes this happen and helps us put our program together. And so I want to thank the Southern California Water Dialogue Steering Committee, the individuals that help us put our programs together, and their names are listed on the slide in front of you right now. So we thank them, and hopefully you'll enjoy the program that we put together for you today. I also want to go through the ground rules for the webinar. And this is just the way that we handle questions and also technical difficulties. So where many of you might be used to using the chat function for communicating about the webinar, we actually use that to let us know if you've got any kind of technical difficulties, and instead focus all your questions in the Q&A feature. So at the bottom of your Zoom screen, most of you are probably used to this by now, you'll see that there is a chat function, a Q&A function, and raise hand function. We're going to ask that you type your questions into the Q&A feature. And at the end of the program, after both of our speakers have given their presentations, then we will we'll go through those questions together. So again, if you have any technical difficulties, please let us know in the chat. And with that, I'd like to move forward and talk about our, oh, I'm sorry, let me talk. I just went through the Q&A, but this is just a real quick, shows you where. Go ahead, move forward. There are a couple of features to our Q&A, and that is if anybody wants to see a question rise to the top of the list, then you can actually give it a thumbs up, and that will be an endorsement that literally moves it up to the top of the list. So we'll look forward to handling questions at the end that way. And we typically do not type the answers into our Q&A, but at the end, if we run out of time, you may find us doing that, or also collecting questions to respond to later. Okay, so today we've got a couple of guests joining us, and we'll have our speaker series that lasts about an hour, and that leaves us about a half an hour for Q&A at the end. We're pleased today to welcome Dr. Stephanie Pincetl and Dr. Erik Porse, each who have an affiliation with the UCLA, but also additional work beyond that. We're talking today about the 21st century of water in Southern California and living within our means. The speakers today have experience in both planning for the landscape and understanding the different water resources we have and how we might manage them to be more sustainable. So with that, I'd like to go ahead and introduce again Dr. Stephanie Pincetl. She's the chair of Environmental Science and Engineering at UCLA's Institute of the Environment and Sustainability. Stephanie, welcome.
Thank you very much. I am really delighted to be here and to share this presentation with my dear colleague, Erik Porse, with whom I've worked for probably over a decade now. We first started working together on a National Science Foundation grant, which was oriented around the question of, will LA go dry? So it just seems so appropriate for us to be able to present our work today when MWD orders cuts to outdoor watering in LA County to 1 day a week, reflecting the fact that actually since we got started on this project of Will LA Go Dry, a lot has changed. in terms of our understanding of, our visceral understanding, I suppose, of water availability into the future. But I think what our presentation today is going to show you is that while indeed the situation of the current period appears to be quite dire and indeed frightening, actually, it offers us a huge opportunity to better understand the kinds of water resources we actually do have available and the ways in which over the past century, our systems of water conveyance and our ideas about water availability as being rather infinite and therefore planning our systems of water conveyance around that concept can be modified to reflect the scarcity of water in the region, but in a very positive way, and that we actually can live within our means, but it'll take some work. Anyway, so thank you. And I'd like to pass this over to Erik, who did the modeling work that establishes that, in our opinion, fact, after which I will be talking a little bit more evocatively about landscape transformation, because I think that's a really important component of it. As we can see with watering outside just one day a week, it's already raising lots of fears, but I don't think it should. It should be really seen as something that is going to move us more into the place we actually live. So Erik, thank you.
Thanks, Stephanie, and thanks, Dee, for kind introductions, and thanks to the dialogue for hosting us. It's our pleasure to be here. As Stephanie mentioned, we've been working on this since 2014, and there's a saying in university research that research never dies, it's only ever abandoned. We haven't abandoned this one yet. We still sort of continue to work on it and enjoy opportunities to discuss some of the findings, but also think about the findings in terms of updated current context. And so that's what we'll discuss today. Some of the findings from our work from 2014 through 2018, but then also within current context. Next. If we want to consider what the 21st century of water management is in California, we're best to think about some themes for the 21st century for our societies more broadly. And these are still our decisions to make as a society, for sure. But what are some of the themes, maybe the ambitious themes that you see emerging? Listed out a few of these. You can certainly think about some more, but these concepts of resilience and reuse and circularity. We have adopted a resilience, quote unquote, paradigm. Resilience has a lot of different meanings for a lot of different fields and people. But in general, we recognize that we don't get to exist within a stationary, a static system any longer, that there are changes, dynamic changes that happen. And in order to adapt to those changes, we need to have flexible systems to operate. And that means fiscal flexibility as well as managerial flexibility and so forth. Reuse, we need to reduce waste. Period, end of story in the 21st century. Our societies need to reduce waste, anything from plastics through to environmental to resource consumption. And then an emergent idea about circularity, the idea that we aren't just using it and then creating waste and trash, that we're actually going to build economies that have circularity, that bring resources, raw materials back into the system. So we reduce the need to extract more from the environmental systems. For most of the 20th century, our economic systems emphasized efficiency, and market systems have done that fairly effectively, one can argue. But you can also argue that in the absence of government regulation or tax policies, that equity has taken a hit. And we've certainly seen some of the ramifications of that in the past years. So in the future, what does equity and efficiency mean within our institutional and governance systems and our market systems? In the 21st century, we also need to recognize that solutions beyond technology. So technology is important, innovation is important. It's a critical component of transitioning to more environmentally friendly societies, but it's not the only thing, right? There's a whole set of laws, institutions, and regulations that are critical as well. And our 21st century recognition, our systems aren't just complicated. They're actually complex. They're more and more complex. And when we make this shift mentally, we recognize that there's a series that complex systems are associated with a series of properties, and that they emerge not only from top-down actions, but also emergent properties that are the sum of actions from a number of different actors or participants. And when we recognize this, we understand why we get outcomes that we don't expect with it that emerge from these sorts of systems. So our systems are not simply complicated, they're complex and should be thought about that way. And then finally, as we recognize more and more, adaptation is critical for climate change, but also within these kind of large, dynamically linked global systems. California is at the forefront of this in lots of different ways. And so mitigation and adaptation will be critical. Next. A few concepts that relate to this idea of complex systems, capacity, connectivity, and performance. When we're thinking about doing systems analysis, oftentimes we're trying to maximize our performance of some goal that we have, right? And over the course of the 20th century, is this whole, kind of idea about performance within systems grew. We recognize we want to maximize particular outcomes such as economic output or maximize efficiency or so forth. But in this shift towards recognizing that systems are complex, we have to have a different perspective. And so one of the kind of default recognitions that we often have is if we can just improve the connectivity in the system, that oftentimes we can make it function more efficiently, right? But for any folks who are out there who might have done a stint in transportation planning, you probably recognize the paradox from mathematician Dietrich Brace, and demonstrated mathematically that you add roads in a network, it may not necessarily result in overall faster traffic speeds. It could actually slow traffic speeds down, right? And so you don't necessarily get from A to B faster because you have more connectivity in the system. And we can kind of draw on this conceptually within management of environmental resources by thinking that in a system where you have lots of different self-acting participants, a complex system, just adding more connectivity, adding more connections between organizations or institutions or infrastructure may not necessarily result in a better solution or an optimal solution. Why? Because in the absence of overall goals, overall normative goals, overall ideas about where we're going to transition to, the self-acting participants will be undertaking dispersed kind of actions, and that isn't necessarily all going to benefit. So we're not necessarily going to have this emergent outcome of a more sustainable water management system without a little bit of thought put into it to begin. Next. What have we seen evolve over the course of the last century and here into the 21st century? As Stephanie had mentioned, we looked specifically at Los Angeles County, but certainly it's a larger linked system across the entire Southern California area. And a lot of the same themes emerge where there's, by the end of the 20th century, suppliers and the wholesalers and the large importer, Metropolitan, were importing significant amount of water throughout the 20th century, but also using additional sources as well. Groundwater is a big component of water supply in a lot of locations, as well as reuse, and supporting some of the groundwater, some of that groundwater pumping through managed and natural recharge, right? But really the bulk of the Southern California metropolitan region was built upon this importing water from several sources. And we know in the 21st century, with climate change, water supply reliability will be impacted. Snowpack will be reduced, right? So there's very likely either through concerted action that we want to take or through drought, there will be a reduction in the reliability of that imported water. And we see that this year. If in the historic record, when we look at droughts in the late 70s, in the late 80s to the early 90s, smaller drought in 2007 to 2009, and then the significant drought in 2012 to 2016, when asking when would the next drought occur, if we asked ourselves in 2016, I'm not sure that very many folks would have said, well, that Northern California would have been entering into drought again in significant below average rainfall in 2019, and then statewide and even westwide by a year or two later, right? So we see a condensation of these frequency and more intensity of drought. And so that leads us to consider what the system is with less imported water. Next slide. And I'm sorry, you can revert back. Yeah. That system changes where we have less imported water. We're reusing more of the water. Some of that reuse is going to indirect potable use, and then eventually direct potable use when it becomes available in California widely. And we're also trying to equate the groundwater recharge and pumping. And that can be through reducing pumping, or that can be through increasing recharge, which has a whole set of technical and institutional challenges, which we'll talk about today. But really, we're discharging less to the ocean, because if we're capitalizing on this idea of circularity, we're going to think about our water cycle being much more self-reliant. It may not ever necessarily be able to entirely reduce imported water to zero, but we are significantly reducing it, and therefore reducing environmental impacts, which we'll talk about a little bit more. Next slide. Thanks. So in the 21st century, you might have heard the term footprint. It can mean a lot of different aspects of, it can mean, what's the footprint of myself as an individual? How much food do I eat? How much water do I drink? What resources do I consume? You can think about that at a city scale as well. And for water management, reducing the footprint of urban water is a way to consider what it means to what it will take to live within means, right? So reducing the footprint of water could be the land footprint, how far we go to get our water, and what are the upstream environmental systems that are impacted. It could also be reducing the energy or environmental impact of the technology that we use to get and treat the water that we consume, right? So we may want to reduce the energy footprint of those processes. So living within means can kind of capitalize on this idea of a footprint and think about changing value structures and tracking data, right? So these are some of the tools about how you actually implement a footprint kind of approach to consider how to reduce consumption sort of in an actionable way. And what are some of the strategies that you might undertake for this? Well, we need to track inputs and outputs across linked water systems. We do pretty well in California of having open and transparent water data now codified in a statewide law, better than a lot of places in North America or across the globe. But what we can do better is thinking about the data across the sectors, across the traditional pipelines of pipelines of water management, right? So water supply, wastewater management, and reuse, and stormwater and flood control, right? Trying to break down the barriers in using inputs and outputs so we can better track those cycles. We'd also think about reducing demand and then reliance, also in turn reducing reliance on imported sources to reduce the footprint of water both in our metropolitan area and how far it extends externally. Think about diversifying and democratizing water needs, especially for groundwater management, which we'll touch on later. Consider boosting local water resources as reducing the footprint of water, especially the geographic footprint on distant locations. And then dovetailing with number 4, reusing and recycling as much as possible. And it's due to treatment efficiency, it's very energy intensive to reuse a significant amount of a very, very high percentage of the water that is effluent, but we can definitely do a lot more in a cost-effective way. Next slide. We'll just kind of go down these strategies and think about how it comes out as actionable tactical items that possibly become implemented. So for tracking flows, when we wanted to ask kind of this big picture question of what's the potential for local water reliance in Los Angeles. We had a number of, we had several linked projects at the city level and the county level in Los Angeles, and a number of collaborators with Stephanie and Mark Gold when Mark was at UCLA, Terry Hogue at the Colorado School of Mines, and Diane Pataki, who's now at Arizona State. So we brought together all these components of the hydrology and the social systems and the technology. And one of the tools that we developed was a county-wide simulation and optimization model for Los Angeles, for LA County water management. And it spanned all those institutional boundaries. It spanned the boundaries between environmental systems, groundwater versus surface water. You could kind of put it all together in this, but in infrastructure modeling is kind of an agnostic tool. You can use these networks to create understandings of linked systems. And then we could use the tool then to run different scenarios. So in this case, if you're trying to identify what's the potential for local water reliance, you would run scenarios of reducing imported water availability and see what the effects are on the system. And we created lots of different iterations of these over the course of 4 or 5 years to look at lots of different aspects of water management and some of the effects of taking different actions. So the cost effectiveness of water management, the energy use of different scenarios for utilities and households, considering effects on stormwater capture and reuse on urban stream flows, all these sort of linked systems that are these big picture, very difficult policy questions to address, which is really kind of the benefit of a tool like this at the countywide level. And really it's kind of one of the largest probably metropolitan systems in LA County for water management in a city and across the globe. And so it lent to kind of some of these big modeling approaches and tools to be able to pull all of these items together. But then also importantly, it wasn't just about the engineering. It wasn't just about quantifying the amount of water. It's about water rights. It's about who manages water and the institutional hierarchy as well, that are this critical kind of component of understanding we have a complex socio-technical and socio-environmental system. Next. So a key strategy, as I've mentioned on a few occasions, is reducing demand. Sometimes it comes in the form of imposed drought requirements, and other times it comes in the form of indoor water use efficiency investments. Southern California has been a leader in doing both of those over a number of years. And when we would run the scenarios in this model, building in an indoor use value, at the time it was equivalent to what was in the legislation, a legislative requirement of 55 gallons per capita per day. And then we would provide some outdoor water use allocations for irrigation, especially for trees, which I'll talk about in a second. And we built in we sort of ran the model, and it would move water through, try to meet demand and using cost effectiveness as the driver for this. We just ran it over and over, lots of different scenarios in lots of different ways. And when you kind of parse this out, it would run over a 25-year period and kind of look at the summary trends across all the different ways we did it. You settled in on this target of 80 to 100 gallons per capita per day of total water use. And so if you go back 30 years, this probably would have sounded absurd as a total water use target. But there are communities in Los Angeles County that are achieving this right now. And as you go forward another 10 or 20 years, you'll continue to benefit from indoor investments in indoor water use reductions, code improvements, and as Stephanie will especially demonstrate, the potential for outdoor water use conservation. And this target is highly achievable as a region-wide or county-wide value. And one important aspect that's come out since our work that we did this in previously is an understanding when you have these longer records of data, it allows you to look at trends in a different way. And so we oftentimes have this idea that we bounce back after drought for the amount of water we previously used. And that's not actually what takes place when you look at it and you try to control for all the factors that change. And that there's this kind of what we termed for a different project, the net drought effect, but our colleagues at UC Riverside and elsewhere have demonstrated this as well. You don't see demand return all the way back up to full demand And especially as those likely drought cycles will continue to compress in the future, and so we'll have them more often, the investments we make during drought to be able to manage environmental water or whatever will persist, right? And so you don't bounce back up to your full pre-drought values. Next slide. A key aspect for the future of water management is landscape transformation. And we'll touch on this, just what was done in the analysis, and then lots more visual representations will come later. So we built into this, our colleagues, Diane Stacke and Lisa Litvak, did sort of the first empirical analysis within an urban setting of going and looking at what water use, how much water was being used by trees of different species. And we were able to build this in based on understanding the sorts of tree canopy cover and species that were in LA County to a sort of a benchmark for outdoor per capita use, which would be sort of the minimum you'd need to make sure you're preserving at least the existing tree canopy. And in the future, what the future will likely hold, a lot less turf grass and a lot more trees of climate appropriate or native drought tolerant species, right? So of the existing tree canopy, as we convert over to different landscapes, much more diversity in the shrubbery, and not necessarily just focusing on trees, but fewer trees that are high water use, and for those trees that do, when they do get replanted, more drought tolerant and low water use trees, climate appropriate trees. Next. As part of this, we worked with MWD and did an analysis of the 2014 to 15 turf replacement program. And I just mentioned it here just to kind of demonstrate, how does this get implemented at a utility level, right? And so we worked with MWD, examined the data and looked for kind of trends in geographic dispersion of where properties were converted and kind of what the resultant landscapes were, and were we getting better landscapes from this. And we had a collection of environmental ecology, biology experts, as well as Stephanie and geography experts in GIS. And so we examined a lot of different aspects of the program, but for the period from 2014 to 15, it was the $350 million allocation during the previous drought. Some of the summary terms that are here. So replacing about 15.3 million square meters of turf, and some remembering the 80s. We examined the subset of data. It was 80,000 properties, and maybe 45,000 of them were in Los Angeles County. We looked at post-replacement landscapes and saw that they had lots of different land cover types, which was an interesting finding. And we also saw a little bit of evidence of neighbor effects. And I mentioned the neighbor effects here because it's a really critical piece, because if we have to invest in replacing these landscapes, we need to recognize how can we maximize the social aspects and the social benefits that can come from this, so that it's not just the water utility's responsibility to be replacing all of these, but we actually need social action towards this and a broader recognition at the societal level. And then also we identified you need longitudinal studies, right? How well do these persist? Next slide. So our colleague Tom Gillespie was able to identify a method using Google Earth where he kind of did a rapid assessment of the resultant landscapes. And we saw a lot of different types of landscapes, like the pre and post pictures. And so you could see, there was some, at the time, artificial turf was allowable for it to be funded. So we saw some turf, artificial turf, also saw some bare ground, but then also saw a number of different landscapes, the diversity of shrubby plants and clustered plants and so forth. And really coming out of this analysis, we were able to kind of see the different landscape types in here and note that, as we'll see a bit later, building on the value of the aesthetic that you can have from a replaced yard, we really want the sorts of landscapes you might be thinking, towards that have shrubbery and diversity, and are recognizing the native plant palette or the local plant palette as well. And Stephanie will talk a lot more about that. Next. So that's on the demand side. And then obviously within a you're a modern water utility, you're looking at both demand and supply. And so what does this mean, this kind of future regime? Like I said, we ran these scenarios and we would reduce imported water use and then see what the results were. And over time, we were able to build in some of the current planned future reuse and stormwater capture, and then had all of the kind of large scale managed aquifer recharge facilities that are in the county already. And LA County's been doing this for a long time, right? And Orange County as well, for sure. It's been doing this managed aquifer recharge for a long time. That's now kind of taking root at the state level in a different kind of way. So if we run through and run the model and kind of evaluate all the different scenarios, we can look across the different scenarios and see kind of what's the percentage breakdown of different supply sources. And so in the graph on the left here, you'll see one of those breakdowns that was published in one of the studies. And we broke it down in terms of direct supply and indirect supply, right? So you have direct supplies of groundwater, imported water, and reuse, right, or recycled water. And then you have indirect supplies of stormwater capture, just because at the time, what we were modeling was not direct stormwater capture and use, it was indirect through the managed aquifer recharge, the large spreading basins, and then end up being used as groundwater pumping later. And so you can see a breakdown here of in sort of the pinkish hue. The lighter hue is historic, and the darker hue is modeled. And from this cost-effective scenario with some amount of imposed water scarcity, there's obviously less imports, but settling out at around 90 to 100 gallons per capita per day, providing water throughout the county adequately in sort of a cost-effective way, right? Now, what we didn't include in this at the time was some of the effects on maybe other systems, such as the need for upgrading wastewater treatment plants or so forth, right? So that wasn't necessarily incorporated in a direct way in terms of costs and benefits. But you do see the opportunity, once you kind of have the construct, the inputs and outputs, that model, to think about much bigger picture questions about not only from the top of the hierarchy, how much imported water is coming from different sources, but what it means for folks having access to rights to groundwater or to different allocations. Next slide. As I mentioned, diversifying and democratizing water management is critical. And in general, generally in society, this is a requirement for the 21st century within these complex kind of complex global landscape and technological landscape that we have. But specifically here, an actual outcome is we need to better utilize the groundwater management, groundwater basins. And that means through broader access and environmental protection. Because if we're reducing availability of imported water, then groundwater becomes a critical feature for two reasons. One, it's a source of direct supply, but two, it's where we hide water when it's available, right? So if we're only relying, say, on imported water during years when it might be available, right? Then bringing it in locally, being able to store it and recharge the basins, some of which have opportunities for storage, continued opportunities for storage. These become critical. And then the next question is who has access to them? And so we did a study came out in 2018, where we modeled some of the groundwater exchange pools, and we were sort of inspired by some of the instances we saw in the Central and West Coast Basin for the readjudication. And what we identified is if you have these sort of exchange pools and you broaden access to them, it can help to reduce the potential scarcity that can come because one supplier or another supplier may have differential access to imports or access to reuse based on their geographic location or so forth. But if you diversify and democratize those groundwater rights that at the time were pretty, monumental achievements within groundwater management in California for sure, as the adjudications were hammered out over the course of 20 or 30 years. How do they play out in the 21st century? Really, we need to broaden access to the groundwater basins for suppliers to be able to weather what's likely to happen with imported water availability in future years. Next slide. An important aspect, as I mentioned, is adaptation. So adaptation to climate change, but also in these kind of linked socio-technical systems, adaptation to changing conditions, right? So we need to recognize, for instance, for water reuse, it's going to be a critical component of the future supply. We have to adapt to changing conditions and build in our recognition that our future indoor use will be less than it is today. And so our expectations of water use, water production through water use have to be lower. And you can certainly identify that there could be a balance in this about the amount that you'd conserve indoor to be able to continue to produce recycled water outdoor. But California's building code will continue to reduce indoor use and produce, which results in less effluent that's produced in future years. So tactically, when you see this in the model, in the modeling, in these kind of scenarios, there will be less imported availability. I'm sorry, if you reduce imported availability, you're reducing demand. Some of the treatment plants throughout the LA County region would see lower flows. But there's also some managerial actions that start to take place that when there's a connectivity available, that some flows get boosted to or maintained in some sort of for instance, some of the reuse plants that are scattered throughout the county. So within these kind of large metropolitan areas in Southern California, wastewater systems, they're oftentimes managed much more at a systems level than in other parts of the state or in other parts of the US. We consider them to be linked systems, and the need for that will only grow. And we also need to connect that up with recognition of what's going on in the water supply retailer or water supply utility at a much more eloquent and intricate level. Next slide. In one of the studies, we had identified sort of an institutional tool. This would be something to kind of drive some change in thinking, right? So full cost accounting across the urban water cycle. Best engineering practice says that you want to use life cycle costs for sure. So life cycle cost means building in the cost throughout the product or commodity or what have you throughout its life cycle. Analogous here is thinking about across the full cycle of urban water. So getting that idea of circularity, right? It's not just the cost of imported water versus the 20-year annualized cost of stormwater capture, but it's the full cycle of the water that's moving throughout the entire institutional system, right? So what's the annualized cost for imported water supply, considering distribution, treatment, and consumption, versus imported water for recharge versus groundwater pumping. And that would include treatment and moving it through the system. And if you're really tactical and ahead on this, then you think about it also connecting in wastewater or the reuse, wastewater treatment and reuse, right? So moving not only just from imports or production, but across that whole cycle: production, distribution, treatment, consumption, collection, treatment, and then reuse or disposal, right? So these are some numbers that did these numbers in 2018, so that I'm sure they've changed a little bit based on some of the emerging strategies. But thinking about this across the whole cycle is really the key. And it'll require institutional reforms, right? Our fiscal systems really don't necessarily allow for this. And this is a really tough challenge to be able to consider these kind of higher level cyclical frameworks that are necessary for the 21st century within 20th century fiscal constraints. Next slide. So what are some of the strategies for living within means? Maximizing use of the groundwater basins. As I mentioned, sort of democratizing and diversifying the rights will be critical to deal with scarcity. Reducing demand and imports. I mentioned both of these are part of the modern water utilities needs, and going forward will continue to be so. Landscape transformation, and we'll have some more discussion on that following with Stephanie's presentation. Recognizing behavioral and social change in water conservation. So going forward, especially for places in Southern California that have invested a lot in indoor water conservation and water use efficiency over a number of years, it's likely that those opportunities will become harder or scarcer, right? So we're going to need to embrace how people respond to conservation actions and how people engage and adopt conservation actions. And this is a much more difficult question, and really not something that research has a lot of great tools to be able to assist with at the moment. So we need new ideas in this one for sure. As I mentioned, the full cost accounting across the urban water cycle. And then finally, it's kind of the vanguard idea. We're likely to see more kind of potential block and district scale projects for distributing infrastructure. But that the end result is sort of this hybridized water system, right? So larger buildings may have treatment and reuse systems embedded or something. Next slide. So just a few ideas to spur some thoughts going forward. So thinking beyond institutional boundaries. So we're going to need creative solutions to reduce water consumption, and they'll increasingly span our traditional 20th century institutional boundaries. So planning across sectors with life cycle costs, that full cost accounting across the urban water cycle is one that I mentioned. Also, how could you get creative about thinking about food waste and embedded water, right? So we know that there's a huge amount of food waste that's consumed. We also know that there's a lot of water used to create that food. But we also know that it's not a direct kind of economic payoff. You can't say if you're a water utility, go and pay a farmer because you're not sure. Maybe that maybe the farming institution is sending their crops elsewhere and there won't be a direct benefit or something, right? But we can hammer this out institutionally. We just need to get creative about it. And then finally, we often use the term energy return on investment within the energy sector, but energy or ecosystem returns on investments. When we make investments in water management in cities, what are the energy and the ecosystem returns on that, right? Thinking about this, and it's not necessarily economic. Next slide. So now I'll turn it over to my colleague Stephanie, who will walk us through landscapes and what landscape transformation really means in Southern California going forward. Go ahead, Stephanie.
Thanks, Eric. I think at the end we'll have an opportunity to answer more questions. Mine is actually going to be arguably less technical, perhaps, but perhaps not. I do think that what the overall message of the work that we did was there's a lot of opportunity to become much more water self-reliant in the region, and that there are a couple of key aspects to this, and that is, partly how our groundwater basins are managed. We have adjudicated scarcity in them in the sense that there's a lot of room left for more water storage, and then how they're managed, as Eric has mentioned. But I'm actually interested in talking a little bit about, obviously, the question of landscaping, because if you just read the paper, like today, everybody is all upset that we're going to be perhaps having brown lawns and what's going to happen to the trees and so on. And I think that it's time to really confront that situation with a different set of perspectives. And so really, this is an opportunity for us to be welcomed back to Southern California, because a century of imported plants and gardening aesthetics has made possible by apparently or unlimited water has led to landscaping heavily dependent on imported water. This is not the landscaping that is a Southern California plant palette. And while, arguably expressing a unique Southern California style, where you are when you're here with the plants that are here. The juxtaposition of camellias and birds of paradise, for example, is just like, whoa, this is amazing. You just put it in the ground, it will grow with a little bit of water. It's also completely overridden place. And one could really argue that it's a legacy of white migration from the East Coast, and then this whole class of gardeners and plant people that came to Southern California in the early 20th century completely wowed by the possibilities of what you could grow here. Well, we'll do some Italian gardens, we'll do some Chinese gardens, we'll mix it all up and have a little bit of both. And it is truly kind of remarkable, the bougainvillea I can see out of my window, for example. But it is an imperialist landscape, actually, if you think about it. And if we begin to shift our outdoor landscaping, it'll really connect us to where we live, which is a chaparral ecosystem punctuated by trees that's full of variety that we don't even know, life and color. The shrubbery alone that existed in Southern California was enormously vital for the incredible bird biodiversity that we had, that we have less of now because those birds just simply don't have the habitat, for example. And I will say that the wild tree canopy is important, and we could talk a lot about that at the end of my presentation because it's a big deal. Trees here really grew in riparian corridors or in places where there was easily accessible groundwater by roots, like the band of the across the hillsides on the alluvial plains is where you found most oak forests, for example. Next. So what learning to live within the region's water regime does is it knits us with where we live, which is a place where we exert water parsimony in the summer. Native plants do not like water. They will die if you overwater them in the summer. Just is the case. They might look kind of dry, but that's what they do when it's in the summertime. With often enough water in the winter when it rains. And that's what the plants like. So they're adapted to this precipitation extreme and to heat. Like plants in the east, they drop their leaves in the winter. You don't expect all those trees to have leaves in the wintertime in the East Coast. Here we have plants that are adapted to hot summers, and they lose their leaves in the summer or they shrivel up. And then you have this marvelous plumping back up with the rain. And it gives us a sense that we actually do have seasons here. People say, oh, well, I don't like California, there's no seasons. That's because we don't see them anymore, because we have everything that is really, really, really green. Because for whatever reason, we think everything should be green rather than understand that actually plants aren't always green, even in the East Coast. So we have these vibrant and green springs with a gray, yellow, brown, odoriferous summer, and it's crackly. And these are our seasons, and we should learn how to embrace them because this is where we live. Okay, next. But saying all of that really comes against a background of difficulty of change. I mean, this is not easy. And one of the things that we found when we did our very, I would argue, somewhat superficial survey for MWD, because they only were there for lots of institutional reasons, we could only look at front yards. The change is difficult because lawns are ubiquitous. Why are lawns ubiquitous? They're not fussy. They can grow in the sun, they can grow in the shade, they can be less watered, they can be overwatered, they can grow on all kinds of soils and slopes. They're really easy to maintain, and whole armies of maintenance crews have their equipment to do so, largely gasoline powered with mowers and blowers that are polluting, right? Well, let's remember that. You walk by those machines and not only are you breathing all of that in, but imagine what the health consequences are for the whole thousands of people who use those on a daily basis, including their trucks. And there's, of course, a whole infrastructure of lawn health, fertilizers, pesticides, herbicides, much of which is equally carbon intensive and gravely poisonous, groundwater contamination and the rest. Lawns are ubiquitous, they're easy, and they're also highly problematic. And in native plants are all about location. The sun, the slope, the shade, the sun, the watering regime. I mean, that's really, really important. They're much pickier. But when they're happy, they really endure those extremes very well. And they are intolerant of supplements and chemicals. They die if you put nitrogen fertilizer on them. And you don't need any mow or blow. So they reduce the earth impacts, but they also reduce a whole coterie of employment, as well as money made in the supplement industry. Next. So the landscape industry isn't equipped to support yet this shift. And I point this out because, if we're thinking about trying to do things in an equitable and just fashion, or in the future, going forward, that is, we have to think about the jobs implications of landscape change. There's a lot of jobs in the landscape change, but there's not a lot of jobs in the long-term maintenance of those landscapes. And so that is a sobering realization, and I don't want to gloss over any of that. Furthermore, nurseries don't carry the natives by and large. Nurseries thrive on volumetric sales of easy to grow and maintain plants. If you go into the backcountry of LA County and you see large scale nurseries, the cost margins and profit margins, I mean to say, on those plants is very slim, and growing natives is much more risky. So you really have to know what you're doing. So there's a whole transition in the nursery industry that would have to take place, and people would have to know the plants that they're selling. I can recall the last drought I went to Anawalt, not Anawalt, another hardware store that had plants that no longer exist actually. And they had a whole table of native plants, and they went and looked at them, and there wasn't a native plant in sight. And so I went to talk to the nursery manager. I said, well, where are the native plants? Oh, these are native plants. I said, no, they're not native plants. They're not native. And basically this person was hired. He was an employee. He could do plumbing, he could do paint, and he could do plants. But was he trained? Not at all. So I don't mean to. So I think it's important to realize that. And the seed stock is scant, especially if you want to plant the species varieties that are local to the specific place, that have historically adapted to that place. So it's not trivial, right? And the labor force would have to be trained as well. So I'm pointing this out because because since we use still, about 50% of water is used on outdoor landscaping. And we are certainly never going to return to a water regime of the 20th century, let alone that we predicated all of our infrastructure on and our landscapes on. This is a big deal. We actually really have to put our heads together and figure out how to make this transition. It's going to take time. It's going to be rough, and people are going to have to get used to it. But if we're down to watering one time a week, I think it's going to be critical that we learn how to live within what this region is and learn where we live again. It's incredibly beautiful here, but we don't bring it home, if you will. Okay, next slide. So changing landscapes costs money and or time. Obviously, only in wealthier neighborhoods is this less of a burden, although they still use much more water than anybody else. So they're really the ones really the neighborhoods that where this change should start. People who don't have much money don't water, by and large, and you can tell, right? There's just not a lot of landscaping. So next slide. So it does mean a new aesthetic. It means new habits. It needs new learning about where we actually live, and embracing where we live in a deep kind of way. Next. So I thought I'd show some examples of landscapes that do exist out there. The Theodore Payne Foundation has yearly bi-yearly garden tours, so people can sign up and go see these landscapes. And I'm going to whip through a bunch of them very quickly just to show how gorgeous it can be. And then I have a couple pictures, few pictures of parks too, because parks are are very important in our daily lives, and places people like to go. And we've been habituated to thinking that a good park has lots of lawns. Next. So I'm just going to go next. Next. So this, the sidewalk, just vibrant set of colors and bushes and opportunities here. Next. And I will acknowledge that not all of these have 100% natives, but they're predominantly natives. Next. So backyard with a fountain, or this is a front yard with a fountain, birds, great bird habitat. Next. Another example, lots of flowering plants. Next. And if you know your plants, you can probably have something blooming all year round. Next. Next. And so these are gazanias in the front. They're certainly not natives. Next. And that's, anyway. So next. And I think I have just a couple more. Okay, city parks. Okay, so I went online and I just looked up parks in dry cities. So next. So you can see, there's a little bit of lawn in the back. It doesn't mean there's no lawn. It just means that you really think about the place and the possibilities of place. Next. A wedding under this incredible oak tree, I think. Next. Lots of shrubs and bushes. Next. Mariachi Plaza. Now, we also need to think about the kinds of open spaces that have some plants, but also create public spaces that are not necessarily mesic parks. Next. So in the Middle East, of course, the use of lawns is really restricted. Next. Or in Mexico, you can see, there are tiny patches of lawns, but lots of public space and benches. Next. Nice allays of trees. Next. And I think that's probably the last one. Next. Oh, no. I think this is in, could be in Sedona, I think. Next. So, thank you very much. And I just thought it was important to show that you can create a lot of beauty, but it's different, and to highlight the complexity of this. In fact, any one of these approaches that we've talked about today, including groundwater management, it's a very, very difficult transition, but it's not an impossible one. And if you don't have any water, you have to make some changes. And we've created the systems that we have today, so you can create different systems. Humans create systems all the time and modify systems all the time. So I think it's a time of enormous possibility, and we should seize the time to start making these changes. Thank you.
All right, well, thank you very much, Dr. Pincetl and Dr. Porse. I'm going to go ahead and get started with our Q&A session. Before I do, I had hoped that Connor Everts, my co-chair, who is with the Environmental Water Caucus and the Southern California Watershed Network, would be able to join us this morning, and he didn't. And that, I also didn't introduce myself. So with full disclosure, I'm Dee Zink. I am the Assistant General Manager for External Affairs for the Metropolitan Water District of Southern California. So yes, we've worked with Dr. Porse on some of his study. And I also wanted to give the backdrop, the references that were made earlier about actions that Metropolitan has taken in the last 24 hours. So as you're queuing up your questions, I'll just tell you that we have a significant portion of our service area, about 6 million people in the parts of the Los Angeles, Ventura County, and San Bernardino County area that are highly dependent on our state water project supplies. And we just recently had those supplies cut back from an allocation. We thought we were going to get about 15% of our supplies, and that was reduced to 5%. And as a result of that, we do not have enough water to meet demands this year. So we have requested water supplies to meet health and safety requirements for this population. And we're really calling on the public to help us to bring our demands down in order to be able to make it through this year with our adequate supplies. So the presentation today is a perfect presentation on the heels of an announcement. What we've called for is for our member agencies to reduce watering across this region to 1 day a week or the equivalent, and this will be implemented at the local level. So I wanted to share that because the way to look at this equivalent is we talked about average use is about 125 gallons per day per person. And we need everybody to get down to about 80. So Dr. Porse, your comment that 80 to 100 gallons per day is highly achievable is very comforting because as you can imagine, we're already hearing from the public who are thinking it is impossible to get down to 80 gallons per day. And it is going to be a transition. It's going to be an abrupt transition in some ways for some folks, but we do have a lot of tools for that. And we want to help both our member agencies, their retail providers, and the public. And so thank you for the presentations today. I'm going to go ahead and start with the questions in the order that they were received. So starting with Diane Wallace's question, she's asking about agriculture as the biggest user of water in California. And how is the usage of more effective irrigation being addressed by small farms and big ag? I don't know if either of you have experience working with any of the agricultural industry and some of the conservation practices, on-farm irrigation practices that have gone to effect, but could one of you respond to the question?
So I think both Eric and I follow this fairly closely, and I would say that there's some very good studies that have been put out by both Public Policy Institute of California and the Pacific Institute, and I think they both show that growers are working to reduce their water use in many crops, and that of course there's a lot of room to go there, but without, as they say, without water, there's not a lot of food. But at the same time, there is some movement on the ag side to reduce water use in growing crops. I'd say that probably the bigger problem is groundwater depletion by agriculture. But it's a very gnarly and big topic. So I don't know. I think PPIC and the Pacific Institute are good places to look. I don't know, Eric, do you want to add to that?
Yeah, just a little bit. There certainly has been a lot of work done for irrigation efficiency, small and large operations. The agriculture sector, water conservation, water efficiency is thought of a little bit differently than the urban sector. The state has moved towards identifying targets for water use based on various metrics. On the agriculture side, it's a bit more supply driven, and then demand is driven more by the market because farmers are responsive to market trends. So there has been an increased efficiency, but at the same time, it has continued to allow the increased efficiency has some other effects of having more acres planted, right? So I think that the future, the study that Stephanie alluded to demonstrates that in the agricultural area, in the absence of thoughtful water use efficiency, the likely outcome will be fallowing just because water is not available. And you see that happening seasonally. But at the same time, you also see demand, they call demand hardening in economics and water management, where we plant trees that use water because they have high output per dollar. So fruit trees and nut trees and so forth. So there's multiple dynamics going on that are driving actions in both ways, and the resultant, until there's real strong groundwater management through the Sustainable Groundwater Management Act, is fully implemented is groundwater depletion.
Dr. Porse, could I just follow up on your study that you did, and you're looking at the full water cycle in Los Angeles County and all of those different sort of inputs from the different agencies and the roles that we play. Can you do something similar in an agricultural area? I would think that you could. And is there a benefit to the shared use of water with agriculture and the other users in a region?
There absolutely is, and there's lots of research around small to medium-sized groups of individuals and groups collectively managing resources effectively. Within California, if you go back 70 or 80 years in the progression of agriculture, we used technology and we used engineering and we used the movement of water to be able to vastly increase the land in production and the types of crops that are available. And that it was highly successful in increasing that availability, right? There are absolutely needs and opportunities for folks in those communities to come together. And part of it is driven, there's a good carrot for it, but there's a big stick too. And that's what the Sustainable Groundwater Management Act attempted to do, or is attempting to do at the local level, of bringing together all the users within a groundwater basin to figure out a plan to manage supply. And the state is going through and trying to serve as this back check for implementing that, make sure it's feasible. And that's an ongoing process.
Thank you. The next question is from John Armstrong, and he is raising a question about the 80 to 100 gallons per person per day. He's asking what's driving that, and I'm going to quote him, bloated number, because he doesn't think he uses that much. So could you talk about what is going into about 80 to 100 gallons per person per day, that use?
It's a good question, because you have to, whenever you look at the numbers, we see the numbers quoted in the press and so forth, you have to look into the details about what number they're reporting. They could be reporting the residential per capita use, which would be all the water that's used in the residential sector, multi-family buildings, single family buildings. They could be reporting total use as well. If we're thinking about that whole water cycle, we're getting towards total use. So that means that per person, all of the activities that you're using to generate all of your economic output, all the businesses, all the industry and so forth, that would be included in total use. So John, to your question, the metrics we provided for health and safety within this modeling used at the time 55 gallons per capita indoor. Lots of folks in Southern California are probably using less than that right now. And the statewide values are somewhere around 48 to 50 gallons per capita per day based on where you can find available data. And then you add in outdoor as well. We kind of looked at what trees and like climate appropriate landscapes might use. And then also adding the commercial water use, which is not used by people, but used indirectly. You go into businesses and you use so there are essential functions that need to be supported, right? But they're managed differently. So if you individually in your household certainly may not be using 80 to 100 gallons per capita per day, and good for you. Lots of people in California are actually, when you a lot more than that. But this is the overall thinking about the full cycle of water. And there's a lot of places in California and Southern California even that aren't at that metric. And Dee mentioned earlier 125 gallons per capita per day. And but again, not sure if that was residential or total. It sounds to me like it might be total, but there's still work to be done. In the US, we still use water more profusely than a lot of other places around the globe.
Thank you, Dr. Porse. Okay, I'm going to go ahead and move to Shelley Billick. Excuse me, Shelley. She's asking about LEDWP's incentives. There are a number of agencies that offer incentives for conservation activities, and she wants to know why they're not enabling retrofits for gray water. I actually don't know if they are or they aren't, so I'm going to take that at face value, and perhaps either of you may know if they do or not. I know there have been some issues or questions about ensuring health standards and things like that, but do either of you have a response to that question?
So I don't know the answer to that either, but I would suggest that it may be more effective to have water recycling at the point of treatment than individual households each trying to do gray water. Because gray water management is actually a fair amount of work and may or may not yield the kind of additional water that pooling all of the gray water together at the or brown or sewage water at the point of collection would. So that's kind of how I think about it, actually, but Erik may want to answer that differently.
Just adding a couple of items. So the state plumbing code was changed.
Yeah.
In some cases, it wasn't allowable maybe a decade ago. So it is allowable now, not incentivized. It's for a number of reasons. It's important to recognize that when you flush your toilet and shower water and so forth, they all have water of different quality. And if you change that mix, we have these legacy investments in treatment plants, and that changes what they intake. And those are critical functions in providing environmental quality. So when you enable gray water, you're taking away the sources that have the lowest level of constituents, and those help to dilute the stuff that has higher levels of constituents and solids and everything else. So there is an effect downstream. But then also there's behavioral changes that need to take place. You need to use different detergent when you're doing this, and then not every household or place can be retrofitted, or renters, of course, wouldn't necessarily have the opportunity to do a lot of gray water other than showering in a bucket or something like that. And so because of this, it's kind of a much more difficult question to incentivize. And Stephanie's right on point that in the full water cycle, gray water can serve some purposes if it reduces stormwater runoff that causes pollution, right? That is a good use of opportunities for capturing on site. But gray water from a household, if that's effectively collected and managed, then that is a featured source of water for a lot of utilities.
Particularly if you're in an area that has a strong recycling program. Not all areas do. And I know a lot of people will be at least bucketing the water in their shower and using it. So appreciate the question. I'm not sure, and I think it might have been you, Dr. Porse, who brought up the term MAR. There's a question about what it stands for, and I apologize because I don't know what it stands for either.
Yeah, I apologize as well for not mentioning it. A managed aquifer recharge. So you go up to Whittier Narrows, those sorts of big spreading basins. And they're kind of nice because oftentimes they have integrated park areas and so forth. We can capture lots of water, and some years LA County can get a huge amount of water stored in those and recharged in those areas. MAR is the engineering term that's used across the whole community, and now it's been adopted by the state of California. But as I've tried to point out to a lot of different folks, LA County has been doing this for a long time. And Orange County too, I apologize, I should have said that as well.
Well, thank you, Leslie Purcell, for asking that question so that we have the answer. We have another question by Sherry Billick, and it's actually a little bit more of a statement, but she's asking about or commenting that many people, particularly in the real estate, a sense of the interest, green lands are associated with economic and class stature. So Dr. Pincetl, you're trying to change how people, I think, view that. And I don't know if you want to comment on that at all.
Well, it's a very difficult, I think I tried to say that it's very difficult. It's an aesthetic change. And it is a socioeconomic issue as well. I know that for some communities, they see these landscapes with natives as messy and dirty and weedy, and really find that it's exactly those kinds of landscapes that are associated with poverty. I mean, I'll just be blunt, and that is, not desirable, obviously. So that's why I pointed out that it really is the wealthier neighborhoods that have to embrace this kind of change in order to make it safe for other places to do it in a certain bizarre way, and also because they can afford to actually make the change and make it facilitate the economic, the industrial infrastructure for those kinds of changes to take place over larger landscapes. We need to make it more affordable, make it more acceptable, and make it more available for the region. And in a lot of ways, having wealthier neighborhoods be the pioneers will really encourage a new aesthetic and new industry. And so not only do the wealthy use the most water, but they have a responsibility to really take the leadership in this kind of landscape change. So I am not naive about the difficulty of these things. And I think but I also think it's absolutely critical, because otherwise, what are we going to have? Dead landscapes? That doesn't seem so attractive to me when there's a possibility of something different.
And maybe use our parks as examples. Hopefully, we have quite a significant environmentally interested industry in terms of our movie industry in this area. Maybe some of our celebrities will take that on and wear it with a badge of honor. So related to the same topic, Stephanie Pacheco has a question about natives. If they take more care, which they do, she thinks there would be a lot of jobs created. And she's asking if anyone has looked into this and how to encourage training in this area.
Well, I guess we have a disagreement about gardening, but since we have natives too, and they don't require a lot of maintenance. So I guess it all depends on the place and the natives. So we'll not dispute any of that. I know that the Theodore Payne Foundation has classes. And I also know that at certain points, the Labor Community Strategy Center, I believe they're called, may have had some classes, but I don't think there's anything terribly systematic, widely available, affordable, and that has enough visibility to plug that hole in. And so maybe it's something MWD will pick up, and maybe MWD will reintroduce really generous incentives for people to change their lawns. There's never enough money, there's never enough time, but it would be great if both of those could be led by our largest water wholesaler in the region.
Well, we do partner with the Theodore Payne Foundation, so we'll look into the training aspect of it at least. Thank you. I love this question. It's about whether there's any adverse, and I just moved past the name. So this is from Jared Lee. Any adverse effects with irrigating native plants with tertiary treated recycled water for the long term?
So Eric, correct me if I'm wrong, but I think that that oftentimes that water has higher salts, right? And maybe some residual nitrogen as well. So it's probably not the optimum water to use on natives.
Right. I think this is sort of the intersection of water reuse expert with a horticulturalist or native plant specialist, and I'm neither, but Stephanie's right on. So you can have some residuals. Something you see in some areas of Southern California is the source water has higher salinity, and that moves through the entire system, and then it becomes more expensive to treat and remove that. And so you can do it through reverse osmosis, highly tertiary treated water. So it kind of depends on the process that's being used, but with tertiary, oftentimes I think with most landscapes, there's not necessarily long-term effects seen. But if you're moving towards more sensitive, native plants that might be more sensitive to, as Stephanie mentioned, sort of fertilizers and so forth, They're adapted to the local landscape. I don't know that I've seen any studies looking at irrigation of native plants with tertiary recycled water. It'd be a good one to study. I think certainly it'll be a factor in future irrigation regimes in Southern California.
And the source water impacts the recycled water on the other end as well. So,
Right.
This question, we're actually getting a lot here, and that is, can most existing trees in Southern California survive on watering once per week during the summer season? And what about grassy areas?
Well, so it depends. I don't think that there's a one size fits all to that, because not all trees have the same water requirements. These are living beings, you know. So I think it's time for us to begin to water trees differently than we have, and shift towards more drip irrigation of trees, longer periods of irrigation for less frequent amounts of time, less frequently. So what we have seen is that trees that are that grow in lawns and rely on surface, that kind of brief surface irrigation, grow roots that are lateral and shallow, because that's water availability that they have. So when there are big wind events, what happens is those trees don't have deep roots and they topple over. And every year when we have high Santa Ana winds, we lose a bunch of trees. We may lose a bunch of trees anyway, but had they been irrigated to encourage deep taproot growth, we might have lost less trees. We also would have trees that are more resilient to less frequent watering, because we would have adapted them to those who need less water to grow that way. So it's kind of a conundrum. We've created urban tree canopy and a set of trees that are adapted to frequent surface irrigation rather than deep, infrequent irrigation. So it's just we'll continue to lose trees until we make that transition, and also begin to select trees that require less water to survive. So, you know, any transition is just really, 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 really tough. And this will be another tough one. And lawns, well, I think lawns are kind of a luxury of the past in most places. We can have small places of turf for sure, but we have to be much less expansive with the amount of grass that we have. We have to shift the kinds of grasses that we grow. There are some grasses that are far more far less water intensive as well. We just have to pay more attention and not assume that anything goes anymore. We've had too much water. One could say, years ago, I used to tell my husband, the problem with water in California and Southern California is we've had too much. And he used to say, what are you talking about? Too much water. But in a sense, you know, we really adapted ourselves to the luxury of having as much water as we, you know, just a lot of water. But we don't have a lot of water. So then you just shift how you use water because you have less of it, right? If you don't have very much money, you don't spend a lot of it. If you don't have a lot of water, you don't use a lot of it. I mean, it is a question of scarcity at a certain level.
That question was from Leon Shapiro, and Diane Wallace has a follow-on question, almost the same, about watering one day a week. And I would just like to add in, because this is something that we're dealing with real time right now, is our understanding is that the grass will go brown, but it likely will not die at watering one day a week. It'll go brown and it'll come back for those areas that you are trying to preserve. But going back to Metropolitan's action today, if we don't see dramatic conservation now to try to preserve as much water for health and safety this month, next month, as we go into the summer, we are at risk of cutting outdoor irrigation altogether. And our plea is for people to save their trees and their gardens and really prioritize their water use outside right now, given the situation that we're in.
Well, if I can add on to that, I like to tell people the water you use on your lawn is the water you're not going to be able to drink. And so, yes.
And that's accurate. Maybe we can tell you. So the next question is actually from an anonymous attendee. And the question is there any plans to bring water from the north or desalination, ways to increase water availability?
Well, we already bring a lot of water from, right? That's the State Water Project, and that's what water is not available at the moment.
Maybe the question is more about local supplies, considering supplies that are not being imported from outside the area.
Yeah, I'm a little confused by the question because that's, I guess, so we have three major pipelines, right? We have the State Water Project and the Los Angeles Aqueduct and the Colorado Aqueduct. And so you're like Southern California is already balancing all those supplies, and that's the mix that's changing, I guess. So one of those pipelines comes from far north, as far north as Northern California, all the way up to the Oregon border, and then the Los Angeles Aqueduct to Mono Lake and Owens Valley is also to the north as well. So the further plans to be able to access more water from those sources is unlikely. Those are kind of very strong institutional arrangements that continue. And LADWP, for instance, is invested in long-term water use efficiency and conservation in the interior, but then also exterior, has been working in the Owens Valley on conservation actions for a long period of time. On the desalination question, most of the desalination projects we'll see sort of in San Diego with Poseidon facility, historic operations in Santa Barbara. A lot of times these facilities were for cities or locations or communities that are sort of at the end of the distributional pipe of the large interconnected intertide system in California, you might say. So there could be some communities that take that on. There's lots of reporting on the potential desalination project that's been in Huntington, and you can read lots of reporting on that to be able to identify what the current evaluation procedures on that is. But large-scale efforts for desalination, it's more likely we might see some brackish water desalination, so taking like kind of saline groundwater and improving that's a bit more cost-effective. So, but still, conservation is one of the cheaper options, if not the cheapest option, and it means changing culture, changing society, transforming landscapes.
Thank you, Dr. Porse. And we've reached the end of our time together today. So what I'd like to do is end on the suggestion by one more of our speakers or questioners, and that's Mia Lair, who is suggesting that the large institutional users like the UC system be the ones to set the example. And I think that's a great idea to end on. So I'd like you all to join me in thanking Dr. Pincetl and Dr. Porse for joining us today with ideas about how we might use our water more efficiently, live within our smaller footprint. And then want to let you know that we will be meeting the same time next month at the end of May. We always meet on the fourth Wednesday of the month from 12 to 1:30 p.m. I would tell you who our speaker is, but we just had a shift and change in our speaking plans. So we're going to notify everybody by mail, and hope you'll join us again next month while we continue to pursue water topics of interest to Southern California. So thank you all for joining us. We'll leave the chat open for a little bit longer as we end the program today. Thank you.
Thank you.
Thanks all. Take care.
Bye.